In this video, we're going to talk about Robbins' definition. This is an important definition in economics. It includes a lot of aspects or topics that we encounter in the study of economics. So it's an important definition. The definition is economics is a science which studies human behavior as a relationship between ends and scarce means which have alternative uses. It's absolutely full of meaning, the definition. All the words have a job to do. And we're going to work our way through the definition, take out the different words and explain what they mean and why they're there. So it's a very important definition. So let's move on with it. It was put forward in 1932 by Robbins, who was at the London School of Economics. That's just stating what I've just said. He was at the London School of Economics, had a long career. This was back in 1932 when he proposed the definition, and this really has become the standard definition now of economics. A lot of other economists have got definitions, but this is the big one. It's full of meaning, and these are the words in the definition, which I think he carefully picked for the definition because they're absolutely relevant. Economics is a science. It studies human behavior as a relationship between ends, the outcomes, and scarce means, which have alternative uses. And what we want to do here is just go quickly across each one of these and say why it's important and why it's there. So that's what we're going to do in the rest of this video. So we'll start with economics as a science. Well, if you do mathematical economics, you'll realize there's a strong relationship with particularly microeconomics in the early stages. Economics and mathematics seem to go together. They don't have to. There are traditions in economics, for example, the Austrian tradition, where mathematics is frowned upon. They do not touch mathematics at all. And there are different approaches to economics that take different methodologies, different routes. Neoclassical economics takes this mathematical route. And if you do economics at university, the chances are you will go a highly mathematical route. It's just the way the world is. There are, as I said, alternatives, but these are not seen as mainstream. Economics attempts to use the scientific method. It calls itself economics as a science. We need to talk about what is meant by the scientific method. Well, to start, the scientific method is to postulate a relationship between two variables. Something affects something else. So whenever we have a relationship in science or now in economics, something affects something else, we have a relationship. We're postulating a relationship. These two things are connected. The price of petrol and the amount of petrol sold, that's connected. That's what we say. Now, we have to establish whether it's connected or not, but we start by saying there is a relationship between the price of petrol and the amount of petrol sold, between the price of bread and the amount of bread sold, between the amount that people get paid for work and the number of people who want to have work. There's a relationship, so we need to determine it. Take an example. Every time the price of petrol rises, less petrol is sold. Now that's just an ordinary English expression. It just says, as the price of petrol rises, less petrol is sold. What we do is we need to collect some data and test it. We can't just say, the price of petrol rises, less petrol is sold, and leave it at that. We want to test it. Is this true? Does it make sense? Is it real? Or am I just making it up? Now, to test it, we need to collect some data to test whether it's actually true. And then when we collect the data, we analyze it to find out what the relationship is. Look at the data. Look at, as the price of petrol rises and falls and varies, what happens to the demand? The amount of petrol sold. How does it rise and fall? So to see if there is a relationship. And once we've found a relationship, we try to generalize. We say, okay, every time this happens as well. Every time the price of petrol rises, less petrol is sold. People economize. It may not last. They may go back because of habits and lifestyle and so on. They may go back to where they were before. But initially they might fall and say, well, petrol is too expensive. I'm not going to use the car. So what we try to do is generalize and say, look, every time the price of petrol rises, less petrol is sold. Every time. We're trying to generalize. We're trying to get a big statement. So we postulate the relationship between two variables. For example, every time the price of petrol rises, less petrol is sold. We postulate the relationship, and in that relationship we have three parts. Every time, we're talking about it being universal here, every time, not sometimes, every time. We have the price of petrol, that's a variable. Less petrol is sold, that's a variable. We can quantify it, we can measure it. We can measure the price. It goes up, goes down. The amount of petrol goes up, goes down. It's quantifiable. And every time. So we've got three pieces of information here. We've postulated a relationship between two of them, and we're saying that relationship is every time this happens. So what we're going to do, we need to collect some data to test it. We have a relationship now. We've got this one here, and we're going to test the relationship between the price of petrol and the amount of petrol sold. We're going to collect some data, and then we're going to analyze the data to determine the relationship, to find out, is there a relationship or not? And once we've done that, we say we have a generalization. We can generalize it. We say, look, every time this happens, something else is going to happen. We generalize, and that's what we do. So if we find as the price of petrol rises, less petrol is sold, we'll go and say, look, every time the price of petrol rises, less petrol will be sold. We've gone from some observations, whatever, 10, 20, 100 observations, we've gone from that to all. We generalize. Every time the price of petrol rises, less petrol is sold. The price of petrol has just increased, therefore less petrol will be sold. That's what we end up with. That's what we've worked out. And we've generalized. We say, therefore less petrol will be sold. That means every time less petrol will be sold. Every time the price of petrol increases, less petrol will be sold. Because we've worked it out from the figures. We've analysed the figures, and that's the pattern that came out, and we're now generalising it. So we have every time, and that's what we were aiming at. The trouble is, how do we know it'll happen every time? That's the problem. How do we know it'll happen the next time? We can't see the future. We are now into the area of something called the inductive method. If you look at methodology and papers on methodology, they have sections on the inductive method. And this is what we're talking about here. We're trying to induce this idea that we're generalizing. We're saying every time the price of petrol rises, less petrol is sold. Every time. But how do we know it'll happen next time? Well, the chances are it will, but that's not good enough. It may or it may not. So there are steps in the inductive method. This is called the principle of enumeration, the principle of counting up. Let's count up and see where we get to. Here's an example. There's 6 white sheep. Now, We've counted these. There are 6 of them. You can count them as well. You'll find there's 6. And all the sheep have white coats. All sheep have white coats. Look at them. They've all got white coats. So now we can go to say, if we only see the 6 sheep, we'll think all sheep have white coats. We've generalized. We saw 1 sheep with a white coat, 2 sheep with a white coat, 6 sheep with a white coat. Therefore we say, look, all sheep have white coats. We've got a picture on the screen. All sheep have white coats. But it's not true. There's a sheep that doesn't have a white coat. And that sheep could be in the majority. There could be 100 of those sheep and just 6 white sheep. We just haven't done all the other 99. So all sheep don't have white coats because we can't tell. If we go back here, we haven't seen the black sheep, so we don't know. We don't know anything about the black sheep. We just know we've got 6 white sheep, so therefore all sheep are white. Now we can't say all sheep are white because it's not true. We can say some sheep have white coats. We move from all to some. All is universal. Some is particular. Some sheep have white coats. We've moved to the particular. So the steps in induction. Well, the principle of enumeration, count up and see what we've got. Generalize if we can, which we did with the white sheep. And we've induced, therefore, from the generalization that in our case we induced all sheep have white coats. But then we found it was not true. So we start again. Here's the deductive method. All A is B. Now, instead of sheep having white coats, we'll just say all A is B. All sheep have white coats. All A is B. We could say, in this case, every time the price of petrol rises, less petrol is sold. A, every time, well, that's all, I should say, every time. The price of petrol rises, that's A, less petrol is sold, is B. So we've broken up our sentence into symbols. We've got all A is B. Now we're given A, the price of petrol has risen. If the price of petrol rises, remember, A is the price of petrol rises. Now we're given A, the price of petrol has risen, therefore B. Therefore, less petrol will be sold. So our conclusion is B. Now what we've done here is we've used something in logic called a syllogism, but we're not going to deal with that here. We do intend to offer some classes on logic later, but not just yet. We're preoccupied by economics and marketing and many other subjects at the moment. So, but it's on the cards. Watch the space. So it's called a syllogism, by the way. Syllogism. Syllogism. And that's a particular, what's called a mood of the syllogism. That's a universal one. All A is B. Given A, therefore B. So we got all A is B by induction, and then we deduced from A down to the conclusion B. And that's all we're going to deal with here. Go back over this a few times, and I look forward to having some interesting discussions in seminars. But in the meantime, thank you for watching.